Good morning, my dear students. In the last class, we discussed about the electric flux. Today, we will talk about Gauss law. Before going to discuss about this Gauss law, let me recall what we have discussed in the last class. In the last class, we discussed about the electric flux, that is the number of electric field lines passing normally through any surface. If suppose that the lines of forces passing through a plane surface, we can calculate the electric flux by using the formula, that is phi of E is equal to surface integral of E dot ds cos theta. This is surface integral, right? E is equal to the electric field lines, ds is equal to the area, and theta is the angle between the electric field line and the area. Suppose if the surface is closed, then we will use the Gauss law to find the electric flux. So to find the total electric flux through any closed surface, irrespective of its shape and size, we will use this Gauss law. We'll take that if any closed surface, we'll take the surface in a small intervals. By taking the small interval of the surfaces, we can calculate the total electric flux close to the surface. Right? So, what the Gauss law says? Let me say that give a statement of this Gauss law. Say that statement of this Gauss law is as here, that is the total electric flux through a closed surface is equal to 1 by epsilon naught times the total charge enclosed within the surface. This is what the statement given by the Gauss law to find the electric flux through any closed surface. The statement is the total electric flux through a closed surface is equal to 1 by epsilon naught times the total charge enclosed within the surface. Mathematically, we can write Gauss law, that is phi of E is equal to Q divided by epsilon naught. This Q is nothing but the total charge enclosed within the surface. We write it as Q encloses. That is the total number of charges enclosed by the surface divided by epsilon naught. We know what is meant by epsilon naught. Epsilon naught is nothing but the permittivity in the free space. So this Gauss law holds good that total electric flux through a closed surface is equal to 1 by epsilon naught times the total charge enclosed within the surface. That is phi of E is equal to Q in divided by epsilon naught. Or we can write, that is phi of E is equal to, phi of E is nothing but the surface integral of E dot ds. That is cos theta is equal to Q in divided by epsilon naught. Right? So, if I say that, how sir we can say that total electric flux through a closed surface is equal to 1 by epsilon naught? Say that here it means any surface. there is a any closed surface, there is a closed surface, and if it encloses the charges q1, q2, q3, then the total charge, what will the total charge of this enclosed surface? The total charge is q in is equal to q1 plus q2 plus q3. Therefore, this Gauss statement is written as phi of E is equal to q1 plus q2 plus q3 divided by epsilon naught, or we can write that is q in divided by epsilon naught. Phi of E is equal to q in upon epsilon naught. Alright, so we can calculate total electric flux by knowing the number of charges encloses within the surface divided by epsilon naught, that is the permittivity in the free space. Okay, so this is very important for the 1 marks question. State Gauss law, write its mathematical form. It is usually asked in the examination. Right, so this is the Gauss law, phi of E is equal to q in upon epsilon naught. Now let us prove this Gauss law. We will prove this Gauss law. How we can say that this q in upon epsilon naught comes, right? So proof of Gauss law. We will see here proof of Gauss law. Proof of Gauss law. So to prove the Gauss law, we will take one surface. Take one surface which is enclosed. Let a positive charge q is placed at the center of the surface, and that is placed at a distance r from the sphere. It is placed at a distance r. Right? So if it is a positive charge, then what will be the electric field lines for this positive charge? The field lines is always away from the charge due to the positive charge. So like this. Right? So we will find the electric field. Right? So to calculate the electric flux to this closed surface, what I will do, I will consider a small Gaussian surface here. I will consider a small Gaussian surface. What is Gaussian surface? Gaussian surface is an imaginary surface where we are going to find the electric flux or electric field. Right? So at this point, I want to calculate the electric field. So the electric flux we can calculate here. So the area vector of this electric field can be written as a n. Now this is the small surface which we are going to be consider where we are going to find the electric field, right? And the electric field and the area vector are normal. This is the electric field and this is the area vector. So electric field and area vector, the angle it makes how much? This theta is equal to 0. Look at it. This is the electric field. This is the area vector. Now, what do we know that according to the Gauss law, phi of E is equal to surface integral of E dot ds. E dot ds, or we write that is surface integration of E dot ds cos theta. So we know that electric field due to the point charge, we know that electric field due to point charge is E is equal to 1 divided by 4 pi epsilon naught Q divided by R square. Therefore, phi of E is equal to, what you can write here? It is phi in surface integration of E dot ds. Here theta is equal to 0, cos 0 is how much? It is 1. So you get what? Phi of E dot ds. Now, if I consider a small surface, small interval of the surface on this total surface, we will get the same electric field. If I calculate the electric field at this point, from this charge at this distance, we will get the same electric field. If I calculate at this point, this point, this point, or this point, I will get the same electric field at any point on the surface. So, electric field is constant. Electric field is constant. What is changing? It is changing the surface area. So, it is surface integration of ds. So, ds is nothing but the small surface. Therefore, we can write E is nothing but what? 1 by 4 pi epsilon naught Q divided by R square. And this surface integral and ds is nothing but the surface integral ds is small areas. These are the small areas. At any point we can calculate the surface area. We get what? What is the area of surface? This is the 4 pi r square. So you get what? 4 pi r square. So this 4 pi get cancelled. This r square cancel. What remains here? Phi of E is equal to Q divided by epsilon naught. Q divided by epsilon naught. This is nothing but the proof of the Gauss law. That is the total electric flux through any closed surface is equal to 1 by epsilon naught times the total charge enclosed within the surface. Right? So this is very, very important. And electric flux. One more point we have to remember here, that electric flux. So inward flux is always taken as a positive. Inward flux is always taken as positive, and outward flux is always taken as a negative. Okay. This is the outward flux. It is negative. If there is an inward flux, you can take it as a positive. Right. So this is the Gauss law. We will see some special cases of this Gauss law. Some special cases of this Gauss law. Usually in the competitive examinations we will use this. So let us come across some special cases in Gauss law. Some special cases in Gauss law. Say here there are three shapes. One, there is one closed surface. There is charge Q present. Second one, there is one more closed surface. And this also encloses charge Q. There is one more. In all of three, the charge encloses Q. What will be the electric flux? What will be the electric flux in all of three cases? Can you imagine? Can you guess? See here, in the first case, there is a spherical surface. In the spherical surface, this spherical surface encloses charge Q. Then there must be the electric flux is phi1 now. Right? And this also encloses the charges only Q. This is the Q. That Q encloses charge Q, so the flux also is same. In third case, this also encloses the same charge. That is why in all three cases flux is same. In all three cases flux is same. In some another cases, say that there is the irregular shape of the body and the charges influenced by this body, that is Q1, Q2 and Q3. Some of the charges are Q4 and Q5. What will be the total electric flux? The total electric flux can be calculated by using the formula, that is Q1, Q2 and Q3 divided by epsilon naught. The charges Q4 and Q5 are outside the closed surface. Hence, they doesn't enclose any charges inside the surface. So Q3 and Q4 does not enclose the charges. So only the charges enclosed by the surface divided by epsilon naught gives the total electric flux. Alright? So this is what the Gauss law, and in the next video we will talk about the applications of this Gauss law. Okay?